Jackie continues with the session. And now let us look at some networking basics, such as switching and routing. In this section, we will focus on general networking concepts, such as network interfaces, gateways, and routes. We have two computers, A and B, laptops, desktops, VMs on the cloud, wherever. How does System A reach B? We connect them to a switch, and the switch creates a network containing the two systems. To connect them to a switch, we need an interface on each host, physical or virtual depending on the host. To see the interfaces for the host, we use the IP-link command. In this case, we look at the interface named etho that we will be using to connect to the switch. Let's assume it's a network with the address 192.168.1.0. We then assign the systems with IP addresses on the same network. For this, we use the command ipaddr. Once the links are up and the IP addresses are assigned, the computers can now communicate with each other through the switch. The switch can only enable communication within a network. This means it can receive packets from a host on the network and deliver it to other systems within the same network. Say we have another network containing systems C and D at address 192.168.2.0. The systems have IP address 192.168.2.10 and 2.11, respectively. How does a system in one network reach a system in the other? How does System B, with the IP 1.11, reach System C, with the IP 2.10, on the other network? That's where a router comes in. A router helps connect two networks together. It is an intelligent device, so think of it as another server with many network ports. Since it connects to the two separate networks, it gets two IPs assigned, one on each network. In the first network, we assign it an IP address 1.1, and in the second one, we assign it an IP address 2.1. Now we have a router connected to the two networks that can enable communication between them. Now, when System B tries to send a packet to System C, how does it know where the router is on the network to send the packet through? The router is just another device on the network. There could be many other such devices. That's where we configure the systems with a gateway or a route. If the network was a room, the gateway is a door to the outside world, to other networks, or to the internet. The systems need to know where the door is to go through that. To see the existing routing configuration on a system, run the route command. It displays the kernel's routing table, and within that, as you can see, there are no routing configurations as of now. So in this condition, your System B will not be able to reach System C. It can only reach other systems within the same network in the range 192.168.1.0. In Linux, to configure a gateway on System B to reach the systems on network 2.0, run the iproute_add command and specify that you can reach the 2.0 network through the door or gateway at 1.1. Rerunning the route command shows that we have a route added to reach the 2.0 series network through the router. Now remember, this has to be configured on all systems. For example, if the System C is to send a packet to System B, then you need to add a route on System C's routing table to access network 1.0 through the router configured with the IP address 2.1. Now suppose these systems need access to the internet. Say they need access to Google at 172.217.194.0 network on the internet, so you connect the router to the internet. And then add a new route in your routing table to route all traffic to the network 172.217.194 through your router. There are so many different sites on different networks on the internet. Instead of adding a routing table entry with the same router's IP address for each of those networks, You can simply say for any network that you don't know a route to, use this router as the default gateway. This way, any request to any network outside of your existing network goes to this particular router. So in a simple setup like this, all you need is a single routing table entry with the default gateway set to the router's IP address. Remember, instead of the word default, you could also say 0.0.0.0. It means any IP destination. Both of these lines mean the same thing. A 0.0.0.0 entry in the gateway field indicates that you don't need a gateway. For example, in this case, for System C to access any device in the 2.0 network, it doesn't need a gateway because it is its own network. But say you have multiple routers in your network, one for the internet and another for internal private networks. Then you will need to have two separate entries for each network. One entry for the internal private network and another default gateway for all other networks, including public networks. So if you are having issues reaching the internet from your systems, this routing table and the default gateway configuration is a good place to look at. So let's take away some key commands from this session. These will be handy in our troubleshooting session. IP link is to list and modify interfaces on the host. IPADDR command is to see the IP addresses assigned to those interfaces. IPADDR add command is used to set IP addresses on the interfaces. Now remember, changes made using these commands are only valid till a system restart. If you want to persist these changes, you must set them in the /etc/network/interfaces file. IP route, or simply the route command, is used to view the routing table, and IP route add command is used to add entries into the routing table.